Video 5, Data Structures. As you write more code, your code will get more complicated and have more components. Think of any app you use. There are many functions or abilities that are built in, all used at different times. By learning data structures, you can create your own functions and pull them for use whenever you need. This helps keep your code orderly and efficient. Create your own functions. To do this, we have to define it in Python. We type out def with parentheses and a colon. Inside the parentheses, we put parameters, which are inputs to the function. Sometimes you want the function to take in things, manipulate it, and output or return it. The colon tells the computer to begin reading the function below. Once again, indentation rules apply. Random. Now is also a good time to introduce the random library. Randomness, as you know, is a part of life, and heavily used in games and simulation. Using the random library, it's possible for the computer to generate artificial numbers for use. Create our own function and learn about the random library as well. The random library is just like math, so we're going to need to import it first. We import random, then we want to create our own function by saying def, which means define, and we need to give it a name. We can call this create random, parentheses and colon, and now we can write things within the function that we are creating. We are going to want to return a random number. You can learn all about random documentation through the Python website. And one thing we are going to do here is random.randint, which generates a random integer n that is inclusive in this range. So we simply call random.randint. Let's say we want a number between 1 and 10. And that's it. This function will return that for us. Outside in the main method, all we need to do is call this method, which is create random. And once here, if we run the code, Python should generate random numbers for us and print it out. So first it gives us 5, if we run it again, it gives us 8 and 7, exactly how it should work. Recursion. This is a special type of scenario, and it's pretty funny if you search it up on Google, because Google returns a funny joke for you. Comment below if you get it. Recursion simply means to run back on itself. It's just like a loop, but it's very small, doesn't require a lot of code, and can often seem efficient. Now let's write a function that gives an example of recursion. One of the most popular examples is factorial. In math, 5 factorial equals 120. Let's see if we can simply write a function that will solve this for us. We can also do this with a loop, but as you'll see, recursion is much simpler. If the number we put in, which is going to be 5, is equal to 1, we know we've reached the end of doing the multiplication, so we can simply return the number. However, if that's not the case, we will want to return n times the number 1 below it. And what we want to do here is we want to call the function again for the number 1 below. And as you can see, factorial n minus 1 is going to loop back all the way to the original function and run this if-else statement again. And it will keep doing this and multiply by the number above each time until it gets to 1, which we know that's when you can stop multiplying because you've reached the end of the factorial. Oops. Alright, once we have that, we can test out our code. We can print factorial 5, which should give us 120, which is what it does. Thanks so much for watching. Make sure to like, comment, subscribe, and share with your friends. Until next time.